I just wanted to go back over this Boyle's Law stuff that we did yesterday. This is, again, talking about the relationship between pressure and volume. And we saw yesterday that it was inversely proportional. As pressure increases, volume decreases. We need to go back again, if we didn't do it yesterday, fill in this graph. This is what a graph would look like if we were comparing volume to pressure. So if this was our variable here, as volume increases, it's getting bigger this way, then the pressure will be decreasing. So it's just a graphical image of how this would look. And we talked about the pressure being how these particles hit the sides of the container, and how when we increase the pressure, so we're making, or we decrease the volume, making the volume decrease, it will increase the pressure. Okay, so let's do a few more problems. So here's one, and these will be uploaded on your It's Learning page for you to go through, and then I'll add some more problems for you to work. Okay, so first thing when we're giving these examples is we're going to read through. A sample of oxygen occupies a volume, so they're going to go ahead and tell you that it's volume of 250 milliliters. And like I said yesterday, no matter what unit this is, it can remain milliliters. You don't have to convert this to liters as long as you're doing milliliters on both the volume 1 and the volume 2. On this one, here's a pressure and here's a pressure, so they're giving us 2. Looks like these two are going together. Here's the volume at this pressure. So that means this is your V1 and this is your P1. What volume will occupy if I change that pressure? So this pressure is doing what? It's increasing. I'm going from 740 to 800 torr. So my pressure too is increasing. So we can already think what we want to happen to the volume. If pressure is increasing, and knowing that this is a inverse relationship, what should happen to the volume? Inversely, it should decrease. So let's set that up using our formula. P1 times V1 equals P2 times V2. That's our formula. We've already identified what our P1 is and what our V1 is. And so P1, we're just going to put that in here. 740 torr. And we can keep it at torr as long as the other one is at torr. And our volume 1, 250 milliliters equals, we have pressure 2 at 800 torr. And we're multiplying that by the volume 2. And we can set it up like that, or we can set it up like this, just showing that we're multiplying. So 740 torr times 250 torr equals 800 torr times V2. So mathematically in my calculator, I'm going to take the 740, multiply it by 250. I can go ahead and hit equal. And then in order to isolate my variable on this side, I'm going to divide by the 800 and get that. So what I did in my calculator is I did 740 times 250. I hit equal, divided by 800, and then that's going to give me my V2. So in this case, seeing what you have in your calculator, and again, we can look at our original and kind of look at the number of, this probably should have had a decimal behind it. So it looks like all these are 3 sig figs. So this should be 3 sig figs. So it should be 231. So 231. Now units should be the same units that my V1 was. My V1 was milliliters. So this should also be milliliters equals V2. We can go ahead and box our answer. And that's the first sample. Let's try to do another one. Okay. All right, sample 2. All right, a sample of carbon dioxide occupies a volume of 3.50 liters at 125. This stands for kilopascal. So when you see now, we have different units. We should be able to identify that liters is the volume. Milliliters or liters will be volume. So this would be V1. And it's at this, so these two go together, so they'll be on the same side, so this would be your P1. Remember from our pressure conversions, there's lots of different types of pressures, kilopascals, torr, atmospheres, several that we're going to be able to use. And it's okay for these Boyle's Law problems to have a different unit, as long, again, as it's at the same on both sides of your equation. So here's my P1 and my V1. What pressure would the gas exert if volume decreased? So here my volume's decreasing, so we should expect that my pressure will increase, knowing that it's an inverse relationship. So again, I'm going to write my formula. P1 times V1 equals P2 times V2. And I'm going to go ahead and plug everything in. So the 125 kilopascals for P1 times V1, this is the V1, 3.50 liters, equals, in this case, they're giving me the volume 2, and we do need to, so P2 is what's missing. It says what pressure, so we know that P2 is what's missing. That's my question. So P2 times 2.00 liters. And just to make sure, these two do have to be in the same units. These are a little bit easier problems right now. So these two are in the same units, and then these two will be in the same units. So my answer for pressure 2 will be in kilopascals. And so we can see my volume was decreased, so we're going to expect that my pressure will be increased. So same kind of math going on here. We're going to multiply by the 125 times the 3.50, hit equal. And then we're going to divide it by the 2.00 liters. And we get 218.75. We only need 3 sig figs for this one, so we're going to round that to 219. So P2 equals 219, and my unit should match my unit for P1, so it should be kilopascals. Okay, I'm going to box that answer. Okay, we'll do one more, and then you will be on your own to do a few more on your It's Learning page. Okay, last one together. Okay, 2.0 liters of nitrogen. You should already be able to get a little bit familiar with that. And when you identify that that's a liter, that you're dealing with volume of nitrogen, has a pressure of 3.2. So since that's, again, the first information given to us, we're going to identify that as V1 and P1. And again, we can see another new variation of our atmospheres being another different unit for pressure. And that's okay, as long as on both sides it's atmospheres. And again, liters instead of milliliters, and that's okay, as long as both sides are in liters. So here's my question. My question word here, what would the volume be? So we can kind of already see that V2 is what's missing, would be at a pressure of, so here's my pressure 2, okay? So P1 times V1 equals P2 times V2. P1 is 3.2 atmospheres. Just taking the information that we identified in the problem. Volume is 2.0 liters. Okay, P2 is 1.0 atmospheres. And V2 is what is missing. So 3.2 atmospheres times 2.0 equals 1 atmosphere times my unknown volume. So we're going to multiply these two in the calculator and then divide by the 1 to isolate this variable here, okay? So in my calculator, I'll put in 3.2 times 2.0, hit equal, then divide by 1, which of course will be the same thing to get my V2. Let's look at what that looks like. 3.2 times 2.0 equals 6.4, okay? Should have been able to do that in our heads. And then divided by 1, of course, will still be 6.4. And so we have 6.4. And I'm looking for my volume, and so it should be liters. And if we put our units in here, we could see that that would be liters, atmospheres, and this is liters, and this was atmospheres. We should be able to see that the atmospheres cancels out and we're left over with liters as our units. So that's kind of easy to see when we keep our units in there. Okay? All right. So now I want you to go and I want you to try a few problems on your own.